Hello, this video is meant to complement lesson 6-4 in our Pearson text with the interactive component. In the Explore and Reason, which is in your companion on page 153, you see 3 graphs, and hopefully you recognize right away that that first graph is an x squared quadratic graph. There might be a translation there, but its parent function is x squared. When you look at the other two, you start to think, okay, well, the third one looks like a flip across the x-axis. And so when you go to Desmos and you just start playing around, which is something I'd recommend that you do, you see x squared equals y. And I remembered, hey, y squared equals x is this blue graph. Hopefully you remember that too. And then that reflection that we talked about can be accomplished by making the a value negative. When you're looking at this, you're thinking, okay, which one would be the inverse? And you remember that when we have an inverse, the x's and y's are flopped. It's also a reflection across the line y equals x. So you can see this purple line. So clearly the green graph is a reflection and the red and blue are inverses of one another. So heading back over here, what is the relationship between the domain and the range of the two inverses? And hopefully you're saying that they are switched. When you think about this, we're thinking that the domain of the left graph is all real numbers, is the same as the range for this middle graph, that y squared. The range of the left graph is then equivalent to the domain of the middle graph. Moving into example 1, we have a use of structure. And so this drop-down menu is really handy and important. The function y equals log base 2 of x and y equals 2 to the x power are inverse functions. The graphs are reflections of each other across that line y equals x. And so as you go through, you start to think about how could I make a graph of this function? And so when you analyze the table, and I have these stacked on top of each other, let me see if my computer will cooperate. I have these stacked on top of each other, and you can see that in my first function, which is the orange exponential, we have -2 would give me a value of 1/4. Well, when we're trying to build the table for the log base 2 of x, we can swap those values. So this 0.25 or 1/4 becomes our x value. The x value from up here becomes our y value. And you can see that throughout the table. So know that it's not our expectation for you to be able to just lickety-split create a graph of a logarithmic function. But what I think is the easiest way is to create the graph for the exponential and then flop those values. In the try it, you're going to be asked to do a very, very similar thing and then check it with the graph. There is a second part, I believe, to this try it, and so now you have a base of 1/2, and so you should be able to do those and check them. And then the whole time we're keeping in mind, what's the domain, what's the range, what's the x-intercept, the asymptote. So once you have them graphed, it's much, much, much easier for you to find all of the key features of those graphs.